Today we'll implement the final part, which is the Thirdweb SDK, to show you how you can connect your Unity games to the blockchain. Hey, how's it going guys? My name's Daniel, aka HashLips, and welcome back to my series where we are creating blockchain-based games with Unity. Now this is part 3 where we'll implement the Thirdweb SDK, making that connection to the blockchain. If you want to follow along, go to the Thirdweb with HashLips playlist and watch these 2 videos. Also, as a prerequisite, you would at least need to have a collection deployed on the blockchain, whether it's the test network or main network. I highly recommend using the Thirdweb platform for this, and you can find out how to do this in this series over here. Now, once we have this, we're going to use this collection to token gate our Unity game. Talking about Unity, thus far we have implemented the main functionality of our game, making it playable. And currently how it works is that you are this little ball character, you can fall in the lava, and you can reach this end goal over here, if I can get this. And finally, okay, good. So we won the game, and then when we win the game, what we want to do is have a mint button as well as a little reward. The user will be able to mint themselves another NFT. Apart from that, we're also going to have an entry screen, which is going to act as our token gated screen. Only if a person has one of our NFTs, they will be allowed to play the game. So let's get started. Currently we have a main scene as well as our goal scene. Now we're going to right click in the scenes folder and create a new scene. This I think we're going to call start. Now let's go ahead and open the start scene. Another thing to do is if we go to file, build settings, we need to add our start scene. And let's drag the start scene to the top. It needs to be the start, then main, and then our goal screen. Perfect. Like we did with the goal screen before, we're going to right click in the hierarchy and then to the UI section create a canvas element. This will be our canvas. So select that and in the middle of the screen press F so we can just zoom in on it nicely. Then for the canvas settings over here on the scaler, we're going to basically say scale with the screen size. This will be 1920 by 1080. Like we did before on the main camera, I'm going to say that we want a solid color, and I'm going to select a dark blue for our start color. Back to the canvas, right click on the canvas now, and let's create an empty object. We are going to call this connected, and we're going to do this again, create an empty game object and create a disconnected game object. The connected and disconnected game objects merely serve as groups. We're going to put some UI elements in the connected state game object. So when a user is connected, these are the elements we want to show them currently. And if they are disconnected, we'll show whatever is in the disconnected state. Now let's create some buttons. Right click on the connected, go to UI and click on button. This will call our enter button. This will use when a user is ready and they have NFTs, and when they click on this, they'll go to the main game. With the button selected, if you press T, you'll find these blue dots around the button. I'm going to hold Option and scale it out a little bit. In order to change the text as well as the size of the text, you have to go to the drop down, select the text element inside of the button, and here we can maybe give it a 30 value, and we'll make it bold. For the button name, again, we're just going to say this is our enter button. Okay, cool. So now we have a enter button, but we need another one for the disconnected state. I'm simply going to copy this, so copy, and paste it in here and drag it so that it is a child of the disconnected state. For this button, we can definitely rename this to say connected, and we are also going to go into the text of this button and change this into the connected button as well. Maybe we can scale this one up a little bit as well. Now at the top level of our canvas, we're going to right click, UI, and create a text element. This will be our welcome. So I'm going to drag this at the top just for organization purposes. Click on W to move it up here, T to scale and hold Option. And then I'm going to change the text itself to say, welcome to the iGame. I'm then going to simply make it bold. Maybe we'll make this text 50. And let's go ahead and align it. Center and center, like so. We are also going to need some text when we are connected to display the user's address and if they have NFTs or not. So I'm going to simply copy this welcome message and in the connected state, paste this as a child, move it up here, and this we can simply rename to address. And I would like this to be in the center as well, and just below the heading. I'm going to make this way smaller, so maybe 30, and that looks fine. We can maybe move it up a little bit. So select it, W, and move it right underneath the heading. We are also going to need some text that's displayed to the user if they are allowed to enter the game or not. Again, copy this, paste it as a child, and here we'll just simply rename this to owns NFT. Selecting the owns NFT text box, pressing W, let's move it down, maybe below the button as a separate message. I'm going to make this 25 and not bold. This will be just a nice little message. Okay, so for the welcome text, what I'm just going to do here for the address welcome text is make that 0. And for the owns NFT, I'm just going to keep it empty. The reason is that we will change these fields with code later on, so it really doesn't matter what it's saying right now. Okay, so now we have a connected state and a disconnected state and our welcome message on this scene. If we are going to hide the connected state, we can do so by in the inspector clicking on this checkbox. This will start off the game with the connected state being in a hidden state. You can see it's grayed out. And with code, we will unhide it if the user is connected with their wallet. This is how things are going to start off. Now I realize something, and I do not want the enter button to say enter button for the user, and also the connected button should just say connect, right? So go into the text and let's go ahead and change that just to say connect. Otherwise it would be a bit weird. Okay, so we have a connect button and a enter button. Now it's time for us to use the gaming kit and Thirdweb SDK to interact with the blockchain through Unity. So if we go down here to the initialization field of how we initialize the Thirdweb SDK, we can see that it is of type SDK. And what we are going to do is initialize ours in the Gurley network. So to add that to our game, what we are going to do is go to the assets, click on scripts, right click, and let's create a new C# script and call it SDK Manager in Pascal case. Hit enter, and then like before, we can go ahead and open it up in our IDE, or you can double click on the script. The first thing that we'll do is at the top, import the using Thirdweb. And we know we have access to that because if we look at the assets, we've imported this package in the very first video. So make sure that you have imported that before you carry on with me. So this is the using Thirdweb, using the namespace of it. And then we get to declare the variables. The first variable will be a public variable, and this will be the Thirdweb SDK type. And we're going to simply call this our SDK. We're going to initialize this SDK in here in the start method, which runs only once. And we're going to say this is a new Thirdweb SDK, and we need to point this to the Gurley test network, because this is the test network that the collection that I have over here lives on. Okay, so save the script. The next thing that I'll do is in the game on the start scene, I'm going to right click and create an empty game object. I'm going to call this my manager object, and this will be where the SDK script will live. So, having this selected, I'm going to drag this SDK manager script on top of this game object. Make sure that it is indeed added as a component. You can also drag it in the inspector. And we can see if we have the manager selected that there's the SDK manager. Now, something to note with Unity is that game objects don't surpass their scene, meaning that if we go to a next scene, we will lose the functionality of this SDK on this manager. So, what this means is that we need to find a way to persist this script throughout our whole game right to the very end where we are going to utilize the SDK again. So a good pattern to use here is maybe to make this script into something called a singleton. This is not part of Thirdweb, however, this is a very good concept to use if you are creating games. The reason is a singleton basically makes it global and also ensures that there's no duplicates of the script, and then you can go ahead and use the same variables. So I'm going to go here, and at the top I'm first going to declare a public static SDK manager. Now this might sound weird because we are referring to the same class that this class is in, right? Or this variable is in. And we're going to call this our instance. So this instance is going to refer to itself, and we now need to make sure that we never destroy the script once we have created it. Or if we have created this and we are using the instance, that we are not using some other copy, but the exact same one. We can do that with an awake function. Now, instead of me writing this all out, I'm going to add it right here below our public variable, the SDK. This is the awake function. It's a private void, it doesn't return anything, but when the script is initiated and created, basically it's going to do a few checks. So basically on line 16, the first check checks if the instance, this variable, is not null, if it's not empty, right? If it does already exist. Now, if it does already exist, we're going to simply destroy the game object that's trying to create the script again. And else, if it is empty for the very first time, it's going to set the instance to itself. And it's going to say, do not destroy on load. Which means when the scene loads, a new scene, it's not going to destroy this game object. So it will persist throughout our game. And we will have access to this public SDK. I hope this is not too complex, but the reason why we are doing this is because when we have the SDK initialized and we connect a user's wallet, we don't want to connect that user again. You can of course create a SDK and initialize it in every script, but then you're going to have the user connect again. And we don't want that. That's why this SDK manager will take care of this, and we'll get to connect once and then use it throughout our game. So let's make sure that we have saved the script, and now let's look at what is next. The next thing is we actually need a script that's going to manage what state we need to display when a user is connected. So in the scripts folder, create a new script, and we're going to make this a C# script as well. And this script will be called Start Manager. So for the Start Manager, let's go ahead and open this up in our IDE. To start off, let's add our two using statements, these two over here. The one is from Unity Engine, and this is so that we can move around to the next scenes. And this one is from the system, which basically allows us to use asynchronous tasks. So add those two. Then we'll need a way to access the UI elements that we have created. We can do so by declaring a public variable so that we can later link up the individual game objects. So we need one for the connected state. We will also need a public game object for the disconnected state, as well as a public game object, which is going to be our enter button, like so. For the text boxes, we can declare them as well because we need to use them. The type is actually from the TM Pro package, Text Mesh Pro GUI. And for the first one, it's going to be our address txt. And then we also need a public for our owns NFT. So txt. So just add these variables and let's go ahead and save this script so we can actually hook these up so you know why I had to declare them like this. After saving the script back in Unity, we can now take this start manager script and drag it on top of the canvas element. If we select the canvas, we can go down and see all the variables that we have declared. And we can now link them up. We can either click on this dot and then just select what element we want. But I feel it's more convenient to click and drag the connected one, put it in there. The disconnected one in here. And then we have to simply do the same for all the other elements as well. So for the address text box and for the owns NFT text box. Great. So now our script knows that these elements are connected and we get to play around with changing the values and determining which one we should show or not show, depending on if we connect it or not. One more thing for the enter button, we need to actually hide this one when we start off. So I'm going to select the enter button and also tick off this, because even though we want to show the connected state later on, we don't know if the person has the required NFT. So that's why we need to hide the enter button initially. Okay, let's see how we can now make use of the SDK to connect a user. In the documentation, we can see there's a section for connecting wallets, and it's pretty straightforward. We'll have to await the sdk.wallet.connect. And if we go a bit down, we can see that we will need something like this. We need to provide a wallet connection, which takes in some parameters. So let's go ahead and do so. The first thing we need to do is maybe create ourselves a new function. The function we will create is a public and asynchronous function. It will return void, and this is how you specify this in C#. And then we need a connect wallet function. Okay, so in the connect wallet function, I'm now going to basically take this code. So we can go ahead and copy this, go to our code, and add it in here. Now there is no formatting. That's okay. I'm just going to indent this a bit. And basically what happens here is that it takes the address from the sdk.wallet connect, and then we provided some options. Now this will connect through Coinbase, and I want to use MetaMask. So I'm going to change that to MetaMask. For the chain ID, I am using 5 because this is indeed the Gurley network, as Ethereum is 1. So just choose the correct ID for the network that you are on. Okay, now we see that the SDK is marked in red, and usually this will work if the SDK was initialized over here, but we don't have it here. We have created this SDK manager, and this is how we will use it. So I'm going to say we need the SDK manager dot instance, and then we can say dot SDK, like so. Now we can use this wherever we want in our code, because we know that is our singleton. So what's next? Well, we know that the user is about to connect, so how about we show them the connected state? And for this, we can just say, set the UI connected state to true. And for the disconnect, we're going to set that to false because we want to hide the disconnected state and show the connected state. So now we know that the connected state will be shown to the user. But before that even happens, let's go ahead and set the address text dot text equal to something. And that we're simply going to set equal to our address that we got from the SDK. Depending on what the address actually returns, we can maybe put some if checks in place to make sure that the user actually has connected their address. For now, this is fine. Now, in order for us to use this connect wallet function, we need to hook it up to the button in our game. So go ahead and open the canvas element and then go to the disconnected state. Select our connected button and scroll down to where it says on click. We can now click on this plus button to add an event. Now it needs some kind of reference object, and as anything in Unity, if you click on that icon, we can now select a script or whatever we need to select. What we want to actually drag into this field is our entire canvas. And the reason is the canvas contains that script that we have created. So back to the button, if we go down, the last thing we need is to select a function. So click on No Function, Start Manager, and at the bottom, it's probably a bit difficult for you to see right now, but the Connect button, the Connect Wallet function is there. So it's the Start Manager Connect Wallet. And that's it. We can now test our game and see if we can connect. However, we cannot click on play and simply do it in Unity because there is no MetaMask. We'll need to test it in the browser. And for that, if you followed the first video, we have set the build settings in place. So we can simply click on build and run. Save this and wait for it to execute, and then we'll test it out in the browser. Our game is now built, and now we can test if we can actually connect. So let's click on this button, and as we see, MetaMask pops up, and I can click on next and connect. And there I can see my entire address. Now I cannot see any enter button because we still need to code that. So let's go ahead and do this. Back in the documentation, if we go to connect a contract, we can see that this is how we connect to a smart contract providing the address. And then we can simply interact with this with a normal standard such as the ERC 721. We can check the balance and so on. So let's go ahead and do this. Firstly, let's go to the code and create a new function. This function will be a public, asynchronous, and a task. We're going to call it check balance. And for the very first line, we basically need this. Let's copy it and then go back to our code and add it here to the first line. Now, remember how we use our SDK is we have to actually use our instance. So I'm going to replace this with our way of doing it. And then we need the smart contract address. We can simply get that from the collection. So I'm going to copy my collection's address, go back to the code, and then we're going to simply add it here. Now we have an instance of our contract, so we can do cool stuff. So for instance, if we want the balance, let's say string balance is going to be equal to await for our contract, which we have now up here, .erc 721, and we're going to check the balance, like so. If you ever want to know what a function does, you can hover over it and see that this gets the balance of the NFTs in this contract for the connected wallet, which should be our wallet. And that is exactly what we need. Now, after we have the balance in a string format, I'm going to add this piece of code from here to here. And this is so that I can explain it instead of typing it all out. Now, for this line, we are converting this balance, which is a string, into a float variable. Then we do a check and see if it's equal to 0. If it is, we're going to set this NFT owns text to this. Sorry, you can't access the game. And if we have it successful, because here it would return and exit the execution. But if it passes, then we're going to say welcome to the game. And we're going to set the enter button to true, making it visible. Now, when would we want to call this function? Well, we would like this to be called after we have connected the wallet. So let's go ahead and call the check balance up here. Now it says that this is a task, so let's just await this. And now we should be good to go. We do, however, need another public function, which will be a simple function that will go to a next scene. So I'm going to call this function enter game, and in here we can say scene manager dot load scene, and the scene that we want to load is our main scene. The one thing that we need to do is actually go to the connected state right now and click on this enter button, and all the way down we're going to simply add an event, drag the canvas, and select the enter game function. Alright, so let's go ahead now and build and run our scene. Building the game might take some time, so just give it some time to do its thing. Now it's built and we can test it out. Let's go ahead and connect, and because we connected before, we don't see MetaMask pop up, so it knows we are here. And as we can see, it says welcome to the game, and I can now click on enter, and I can play the game that we have created. If I reload, and let's go ahead to MetaMask, and let me disconnect from here, and let me switch to a other wallet. If I refresh, and I say connect, and I connect to this wallet, it's going to do the check and say, sorry, you cannot access the game, because this wallet doesn't have one of these NFTs. However, if I go to the NFT collection and now connect my wallet over here, I'm going to mint myself one of these NFTs to see if I can gain access. So let's go ahead and mint one of these NFTs, say continue, and let's wait for the execution. Once this is done and this transaction is through, we're going to refresh the game and see if we have now access. As we can see, 2 NFTs have been claimed, and I do indeed now own one. So if I go back to the game and reload, and we connect, we should now have access to the game. Perfect. So our logic works. Now our game works, and if we go to the end goal, then we would like to claim an NFT. So let's go ahead and program that. Go back to Unity, and now we are done in this scene. So let's actually go to our scenes and go to the goal. Here we have our canvas text, which I'm going to move up now. Then right click on the canvas and let's create a new button. This button I'm going to call my claim button, and we are going to use this to claim our NFT. As usual, I'm just going to press T, hold Option, and scale this out a bit. And for the text, I'm going to say here, claim, and let's make it a bit bigger, maybe 30, and bold. That's good enough. So now we can go to our assets and our scripts. And as we did before, we're going to create a new C# script, and I'm going to call this the Claim Manager. Let's go ahead and open up Claim Manager, and all we need here is a simple function. Now I'm going to actually put 2 functions in here, and let's not forget our import statements at the top for Thirdweb, as well as this asynchronous task. Okay, so basically what these 2 functions do is this is our task, which is the claim NFT. We get an instance of our contract like before, and this time we just say contract.erc721 and claim, which would claim an NFT from a drop contract. It knows what contract to claim from because we specify the address over here. And then I've got a separate function, and this just simply says claim. The reason is I'm calling the top function in here because maybe I want to do something else later on before I actually claim the physical NFT. So I just have this one as well. Let's save this script and go back to our program and take your claim NFT manager script, the claim manager, drag it on top of the canvas. Make sure that it's there. Then select our button, add an event, and this seems very familiar. Drag the canvas, select the claim manager this time, and the claim function. And now, ladies and gentlemen, our game should be complete. Let's actually go ahead and go to the first scene, and let's go ahead and build the final game. We'll say build and run. Give it some time and let's test it out. So like before, we get to connect and then enter our game. And this time, if we hit the goal at the end, we get to the winning screen. And if I click on claim, hopefully MetaMask will now pop up and ask me to claim one of these NFTs. And I'll say continue. Now, this is the full example, but I've got something special to show you as well. Here is something cool that you can try as well. My game I've built in a folder that's living on my desktop, and here it is. So if I open my terminal and I go to that directory, and how you go to directories with a terminal, which I'll make a whole series on, is you change directory, type cd space and the full path to your actual game. We can verify that we are indeed in the games folder because there it is. And now what we can type is npx thirdweb latest upload and a full stop. Hit enter. This will ask you if you want to proceed and just say yes. If you want to upload your game to IPFS, that is. And this is exactly what's happening right here. Thirdweb is going to now allow us to upload our game to IPFS, and we'll play it straight from decentral storage. How cool is that? And there we go, it's done. And it's living on this link right now. So if I open this up, I should see my game playing. And anyone can actually visit this link right now. However, I'm not sure if you will be able to connect because you don't have one of these NFTs. But this is living on IPFS. And I think this is pretty cool. I really hope you enjoyed your time with me with this series. If you did, give me a subscription and also a like and comment on videos. It really helps out my channel. And till next time, I'll see you in the next video. Cheers for now.